All right, so welcome everybody. Lalita will help organize and pose the questions to us. And please, Lalita, go ahead.
Yes, so good afternoon, everyone, again. So today we will do like panel discussion on artificial intelligence and urban mobility. And today we have three questions, and and our professor will answer each question, and we would like to maybe go by our in order of our professor last name. And since we have a limited time, maybe I would kindly ask that we keep it a little bit shorter, maybe like 1 to 2 minutes per professor. And then we will end the session with students' question that the student have posed on Meta Campus, or maybe the student might have questions during the discussion. So maybe I will start with the first question and I will type that in the chat as well. So the first question is maybe can all the professors think of an example in which artificial intelligence has changed urban mobility system? Maybe we start with Professor Bruno.
Fine, thank you. Good afternoon. Thank you for this question. Well, there are already expert systems from the late 90s which have evolved, and this expertise has become, from some point of view, an artificial intelligence. But it's something that is able to apprehend, to include inside the operation the experience that has been taken in 20, 30 years. So you were asking for an example. I make the example in this referring to the city where I live, that is Turin. In the 90s, the Utopia supervisor system was introduced. Utopia is a supervisor able to monitor the traffic in great part of the city. Consider that Turin has something less than 1 million inhabitants and something like 1,200 crossroads have been equipped with inductive loops and other traffic monitoring systems in order to monitor the real traffic. And at the beginning, this could influence just the green light and the red light in the phase of traffic lights, and let's say help the traffic flows. But in the years, the instant monitoring has become an historical trend. So even if some inductive loops do not work anymore, you're able to trace what is the typical traffic trend in that crossroad, considering the classification where you can insert it. What do I mean by that? That at the beginning of each day, you can classify that day as with the sun, with the fog, with the rain, with the snow, then schools open or school closed, strikes or not strikes. And you can classify, at the beginning there were 64 typical days. And by gathering and collecting all data in 20, 30 years, the supervisor is able to predict what is going to happen. This is something similar to artificial intelligence, but there is still, let's say, an expert system behind that. Then in the years, the subject of which we have spoken about a few weeks ago, the traffic light priority for public transport, in particular tramways, has been introduced. Why? Because the system had become, in the meantime, so expert to give priority, but considering the traffic flows that would have expected on that typical day. So this means that this original, let's say, low-level expertise has become so expert that somebody says, well, that's artificial intelligence. But is the accumulation of historical data introducing priority for public transport, helped by let's say, Galileo localization. This is not widely available as a matter of fact, but anyway, the integration of odometer with GPS could allow in the years to localize in a better way the vehicles, the trams in particular, and then to refine, to tune in a better way the traffic light priority considering the other flows. So I conclude saying, artificial intelligence is not something new. Is the evolution of expert systems which could accumulate, in some cases, I just referred to the city of Turin, an expertise so deep that nowadays all the things seems, oh, that's artificial intelligence. It's just expert that is accumulating experience inside the supervisor. Thank you very much.
Okay, thank you so much. Then maybe we can move on to Professor Eric. So do you have any example of AI or how it has changed urban mobility?
Yeah, indeed, I think traffic control is one such area that Bruno mentioned where AI has been around and is continuing to evolve. And it's an area where there is a lot of data that can be collected through sensors. And I think that's true in general when I look at areas where AI is popping up. It tends to be in areas where there is a lot of data to be gathered and that are gathered, and especially areas where we see new kind of actors entering the mobility arena. So I'm thinking, for example, about micromobility services like shared e-scooters and shared e-bikes, where we have startups popping up within the last few years with that essentially come from the computer, the AI industry rather than the traditional transport industry. So I think they have AI methods in their blood in a different way. So when they are working with their fleet management and things like that, they tend to think of those problems with AI solutions. Also, of course, autonomous vehicles, which maybe have not yet changed urban mobility. It's for sure changing urban mobility right now and probably will do so even more in the future. And again, this is about collecting massive amounts of data through the sensors in the vehicles and collecting information from other vehicles or from the central system and getting it out to the actions of the vehicles. So there, AI is used a lot to control the vehicles, synthesize all the information and make smart and safe decisions based on that. Right, thanks.
Okay, thank you so much. Then how about Professor Eva?
Happy to. All right, so I think when we look at the amount and number of AI-driven innovations coming in, I think it is historically still traffic management systems where we see how they can dynamically change traffic lights, for example. And I think the other area where I feel like it has not just micromobility, but generally shared platforms where you have now machine learning algorithms who basically match driver, let's pick Uber or Lyft, where they match drivers to the demands and optimize routes. I think that's where we see the most AI-driven influences. I think another topic I would like to touch here also is talking about the cities where they're being implemented. And I hope my colleagues agree. I don't think it's necessarily Europe. I think where we see the most new AI-driven innovations are usually in Asian countries, Singapore, for example. And I think the other cities where we see a lot is the southern US cities like Los Angeles, where you see new innovations pop up, where you basically have the right temperature, you have the right, I would say, environment for those systems. So still in Europe, we have a lot of privacy laws and data protection laws where sharing is very restricted, I would say, for very good reasons. But I think that's where we're at within Europe. Thank you.
Thank you so much. Then we can move to Professor Madevonic.
Sure. So I guess what I can give you as an example is what Helsinki region is doing right now. We're just having like a data pool to combine sources of different data to deal with maybe a more difficult question than traffic operations questions, and that question is behavioral change, habit change. So mobility is a habit. So and for that you need to find sort of segments of people and what kind of attitudes need to change, motivation, opportunities, those kinds of things. So that's what we are dealing with right now, at least in Helsinki. So I will keep my promise of being short.
Thank you so much. Then we can move on to Professor Philippe.
Hi, everyone. So when I thought of this, well, I totally agree with everything that was said, so I won't repeat what was said. But when I digging into the question is, did AI change the urban mobility system? And building on what Milos has said, is I think we are still at a very early stage to see if things changed in reality. Even if you were talking about traffic optimization, the gains are below 20% most of the time in terms of travel time. So is that really an impact or not? So I truly believe that we are beginning to, using the capabilities of AI many ways: prediction, optimization, perception, matching, accident detection, everything. But still, we are not in the position to say if it's change or not, even with the autonomous fleets. So we still have to deploy things and make evaluation of impact. I'll keep it short as well.
Okay, thank you so much. Then we can move to Professor Frances.
Yeah, okay. Let me show you a picture. It's oops. If I can you let me show a picture? Share the screen.
Maybe can you make a request again? Then maybe I can.
No. No. I'm not allowed to share the screen. Well, it doesn't matter.
So sorry.
No problem. Well, I made a picture that you can imagine. Imagine two S curves. We have a vertical axis is the implementation of a mobility system. A horizontal abscissas is the time, and then we have two S curves, and then they split strategic issues, tactical issues, and operational issues. Strategic issues are related mainly to infrastructures, civil engineering. Tactical issues are related to industrial and mechanical engineering. And operational issues deal with data and deal with technology, information technologies. Well, in Europe, we are pretty good at the infrastructure level. We are pretty good at the tactical level, and we are implementing this in technology, information, big data, artificial intelligence, whatever. When Bruno started talking, I remember that, yeah, when I started doing my PhD thesis, everybody was talking about expert systems, and that was one of the main ideas. I had several. This was one, expert systems, that was in 1983, 84. Then I switched into value of time, and then I went to the US, and then I did something else about logistics applied to airports. Nothing to do. Well, what I mean is that the marginal contribution, the largest one is strategic planning. Then a little bit less is tactical planning, and operational planning, it's okay, but it's around 10 to maximum 25% of improvement. So these artificial intelligence implementations that we are seeing, they are not disruptive, they are an improvement. I asked several artificial intelligence to tell me this, how AI has changed urban mobility. And then they give me several examples, like 10. I use several. One was adaptive traffic signal control in Pittsburgh, in the US, but there are several other cities that they have this. Well, I can tell you that this, I don't believe the figures that they say that they improve the travel time 40%. I was arguing with the artificial intelligence. I said, "Are you kidding?" Well, yeah, you are right. It's 40%. Maybe it's marketing. It's a marketing figure. No, it's okay. If it's 10, 15%, I believe it. I can tell you how they do it in Barcelona. They don't apply artificial intelligence, but they apply something pretty smart. They have several fixed plans that they change according to the day and according to like 6 plans per day, every day, and they are different. And then they have cameras in like 10 or 20 key intersections. And with the cameras, they see the fluctuations that we always may have. And then they have transition plans so that if we have a queuing problem in this street, we need to evacuate that queue, and then they implement a transition plan that gives more green phase to that street. Pretty smart, but not too sophisticated in terms of artificial intelligence. They gave me another example, mobility as a service in Finland, in Helsinki, the WHIM app, created by Sampo Yetanen, but it went broke 1 year and a half ago. I asked, they gave me some figures. They say that the public transport use increased by 12% and private car ownership among users dropped by 9%. I argued. I said, I'm sorry, but I don't believe that. Well, you are right. You are right. This is about the guys that were members of WHIM app. Okay. And then they told me about demand responsive public transit in Singapore. We have this in many cities. Driverless robotaxis in Wuhan, in China, and some other places in San Francisco, whatever. Well, yeah, they go slow. It's a improvement. Are they cheaper? No, not necessarily. For example, they are cheaper in China because they are subsidized, but not in the US. They are sold like a luxury, like a experience, a new experience to you, no? And then finally, just to finish, artificial intelligence powered emergency vehicles in Fremont, in the USA. The figures were amazing. 62% of reduction of emergency response time. I don't believe that, man. And it's impossible. And they said, well, yeah, you're right, because we don't have that. And when they use the sirens, and then people move. And of course, probably there must be a better way of doing that. But the improvement has to be 10, 15% at the most, regarding to what we do in most of the cities. And then they were saying, yeah, you are right. AI-driven public transport in Berlin, another example they gave me. AI for traffic flow in Amsterdam, ride-hailing and micro-mobility in several cities, autonomous vehicle testing in San Francisco, Phoenix, and Beijing, and public transit predictive analytics in London and Singapore. These are the examples that none of them to me are disruptive, all of them are improvements.
Thank you so much. Then we can go to Professor Luis to end this question.
Hello to everybody. Well, I'm struggling with some network issues because of the connection. And I am also from the University of Lisbon, like Flip. And so after all the interventions, it's difficult to give an example of the, let's say, how AI has changed the behavior. But nevertheless, I will give an example that it's a real example for a motorway operator, urban motorway operator in next to Lisbon. Actually, they change in the last, let's say, 5-6 years, a kind of approach that allowed real-time improved decisions about traffic management, dynamic traffic management. And so this is actually an application of artificial intelligence, machine learning algorithms, but the application, let's say like this, is used, the models used can readapt as behavior patterns change a bit. And this is applied through dynamic speed control in order to, for instance, from the incident patterns, try to prevent crashes and deal with disruptions like roadworks or seasonality, because we are in general talking about urban motorways very much influenced by a demand that change with the seasons. So it's just an example, and I rest here. And for the rest of our conversation, I leave the expenses from our side to Philippe, because my network connection again is not very good. But I will remain here. Okay?
Okay, thank you so much. Then maybe we can move to the next questions. So we already discussed how AI can change urban mobility. Then we
Lalita,
can
ask question 2 and 3 together because we're almost at the half point. So,
okay,
and we would
yes.
like to have the students answer too.
Yes, so whether we can move to like whether introduction of AI has made mobility system more sustainable, and also what do you think are the upcoming challenges of AI that AI is poses on our European mobility system? So maybe we can start with Professor Bruno again.
Okay. Yes, thank you. Well, first of all, I have to tell you that I don't believe too much on artificial intelligence, but I think that as much as an expert person doesn't have the time, the sensibility, the accumulated knowledge to manage something, the evolution of expert systems towards artificial intelligence and machine learning can help. I make you a very practical example that is not referred to traffic, to other examples we made before, that is that of ropeways, urban ropeways, of which we have had the possibility to speak about in the past. Urban ropeways have a very short time for maintenance and operate all the year long. The main example is Latin America, where in 15 years, as we have seen, they have built 35 urban cableways. And the problem is that there is not much expertise in cableways, because this expertise has started mainly in Europe in the beginning of 2 centuries ago. And at the same time, there are problems, components, roads themselves that have to be monitored. And within that, they speak about artificial intelligence, but is again the collection of a lot of data, which through machine learning, clustering techniques sometimes help to identify in a quicker way where the problem is arising to, let's say, help prognostics, that is, advanced diagnostics that help you to know in advance where a problem is raising. So my first answer is the best applications are where you have a lot of data, less expertise, and the instruments, which is recognized sometimes as artificial intelligence, but again is an evolution of machine learning on one side and expert systems on the others, allows you to help to identify something. But again, the knowledge of human being has to be there. Because if you assign to a person, sorry, with maximum respect, to an expert in statistics, oh, there is a problem. Look, that is that problem, not just a number that is evolving. So you need to know what is happening. So this is a first main answer. Then a second shorter one, referring to the case example that I mentioned before. So Utopia in Turin, supervisor, traffic light priority for public transport and so on. There have been different publications. They are different. It's difficult to sustain or to say, well, they are not right. Anyway, there are publications. More or less, they say that the effects on CO2 emissions deriving from these expert systems and nowadays probably possibly artificial intelligence is something like around 20% of reduction. I don't know if it's correct or if it's not. It seems reasonable because this means that if you switch off the system, you have a traffic that is not controlled anymore in that way, not considering the actual values, and it's quite credible that you increase local pollutions and global emissions. So if we want to quantify, certainly switching off and switching on the system can help, especially if you start monitoring some variables at the beginning of its application. And I think that that can be useful. But again, there is a mind behind that, not just a software operating.
Thank you so much. Then we can move to Professor Eric.
Yeah, regarding the sustainability effects of AI, I think definitely we have mentioned examples of improving throughput in traffic control, traffic intersections, and reducing crowding, congestion, and so on. That can lead to local positive effects on sustainability, increased traffic safety, and so on. But per se, AI will not help finding a better global outcome of the mobility system. If we improve car traffic too much, then we might attract travelers from public transport or the active modes, for example. And we still need the planning to do that, to coordinate and make sure that the overall planning of the mobility system makes sense. Then, of course, we have the energy consumption of AI itself, which we know can be enormous. And I think that it's at the moment very hard for the planners, the mobility planners, to have a sense of those external negative effects when they use AI, since we need to balance the positive effects on the mobility with the negative external effects. Also, maybe just to add another use of AI we haven't mentioned yet, I think is in the planning process itself, there is a lot of administrative works in producing plans, documents, etc. And I'm sure AI is used already to a large extent there, and I can see that continuing even more in the future. And I think that's both for for the better and for the worse. But I'll stop there for now. Thanks.
Thank you so much. Then we can move to Professor Eva.
Sure, of course. So I think AI is making our mobility systems more efficient. So I think that we would agree on. But the more I'm researching on the topic, the more I'm convinced it's actually not making it sustainable. Simply because, as Eric mentioned, it's the energy that has to flow into it. What hasn't been mentioned is, for example, also the time that it takes to learn about it, to apply it, to keep up with the latest knowledge, to implement it, compared to what we actually know. And that is if we walk, if we have active mobility, if we want to foster health and foster our mobility systems to be efficient, we have to go back to the basics. And I'm not sure whether we can. I think there's this one famous, it's obviously not mine, the one famous example, how do I make a traffic system safer or better and bring back the stick shift, right, for cars, because then no one can text anymore. It's basically, I think we should think about moving backwards in terms of AI has given us a very powerful tool, but do we actually need it to create a sustainable transport system? So that I don't think we do. Thank you.
Thank you so much. Then let's move to Professor Milos.
Yeah, so I very much agree with what has just been said, Eric. Eva. The answer to the first question is no. I mean, transport system is the worst kid in the class. It's the least sustainable system we have out of all the different societal systems. If I push the reason why even further from what has just been said, we have a governance problem. Yeah, that behind all of these problems, we have a many hands governance problem, and more knowledge. Although I work in a knowledge production organization, is not always what we need. Yeah, we need better communication processes in these governance systems. So, and oftentimes AI is not actually helping with that. As far as the challenges, if we stay in Europe, very much agree on the energy consumption part. There are, of course, various other environmental impacts, water consumption, and so on, that come from these AI centers. But on top of that, what I, of course, have to recognize nowadays is that the questions of sort of data ownership processing, especially in times of, as we all are painfully aware of, geopolitical changes. So, are we going to wait for one day that someone just closes the tap on the algorithms that are from the other side of the globe? So we'll see if that will happen or not. So I think we have to recognize that geopolitics is one of these challenges behind. That's all.
Okay. Thank you so much. Then we can move to Professor Philippa.
Okay, so going to the second question, if it makes the system more sustainable, we always have the triple bottom line with typical pillars of environmental, social, and economic sustainability. And I think when we still tend to look at the efficiency of a system pretty much from an energy and emissions, whatever are the environmental impacts, and we tend to forget the other systems, specifically the social system. And in that sense, we have examples where AI can tend to make current inequalities worse, social territorial inequalities. We have the example is with the deployment of micro-mobility devices like e-scooters, where they tend to concentrate and locate those devices in the beef of urban mobility, which is a city center that already has high accessibility, exactly, public transportation and other the modes like walking and cycling without being shared mobility. And so this is one example where the use of AI in the relocation of devices can make social territorial inequalities. So it's not sustainable in that sense. and these are direct effects, I would say. Even if you make, for example, travel speeds smoother or less idling or fewer breakdowns because you are optimizing traffic flows, for example, you still have the indirect effects always with the induced demands, more vehicle kilometers traveled, and so on and so forth. So, and this is not because of AI, it's because AI makes things efficient, and we always have rebound effects. We don't know what is the extent. In the case of autonomous vehicles, the typical thing of relocation of vehicles, they're gonna park, or they're gonna just drive around forever. So there's still many unanswered questions at the end. But definitely, if we want to kind of regulate the system, we might have an unsustainable path of development. Regarding the main challenges, I mean, I totally agree with what you said. We have the governance problem. We have cybersecurity. These equity has to be also taken care of. So if we build KPIs to evaluate impacts, again, should include KPIs for social aspects in the evaluation. These and also something that is unavoidable from a Schumpeterian perspective, which is the creative destruction of AI, is also a challenge regarding workforce displacements and I mean, what are the impacts this has also in the workforce for transportation. So I'll keep it here, and this is already quite a lot of challenges set. So a lot of work to do. Thank you.
Okay, thank you so much. And we can move to Professor Frances.
Yeah, I agree with what Eva said, that AI is making the system, the mobility system, more efficient, but not necessarily more sustainable. I think in the short run, in the short term, it looks like it's more sustainable because because of the efficiency. But in the long term, this is questionable. Okay? AI, it's being used to maintain the current car-centric system more efficiently, yes, but it's the same car-centric system, rather than transforming it into a truly sustainable system. And to answer the second question, I agree with Professor Milos that, yeah, our problem is governance. Let's see if I can share another picture. I don't know if, can you see it?
Yes, Francesco.
Yes. Well, I think this, since I showed this in one of the talks, some international innovations related to weapons, to funny things, SpaceX, whatever, things that are pretty sophisticated, some of them transportation, like magnetic levitation in China. Well, our innovation in Europe, it's pretty, let's say, it doesn't solve core problems. And yeah, the problem is that Europe is not a country, like a solid country like the other countries. This is Europe. It's not the white part on the left, it's the right part. And then the question is, who rules here? And what are the rules? We are trying to make an artificial intelligence more human-centric, but we lack of governance, and we lack of also even ethics to do this deep research that we don't dare to assume that the destiny, the objective, the final objective justifies everything, like Machiavelli used to say. We don't like to do this. We are more trying to protect data and our people rights, and then that's why we are not going to produce as good research in artificial intelligence applied to mobility, usually private mobility, that like any other country, like China, US, or some other countries. That's it.